Great. It's my pleasure to be here to present this webinar on Dublin Airport's geothermal journey. So I've been at DAA since May of 2024, and the journey did start before then, but I've been helping it along since then. And we're certainly not at the end of that journey, but happy to kind of take a pause here and share with the group just where we're at and where we've come from, giving some insight into how geothermal might work in an airport context. So thanks for having me, and we'll crack on. So I suppose our journey initiated in sort of 2019. As I mentioned, I joined DAA in the Dublin Airport in 2024, but there was some work before that. Obviously, Dublin Airport and DAA have been always looking at sustainability projects, but in 2019 we embarked on what's called our capital investment program. And then in 2020 with COVID, there was an opportunity to do a redetermination to essentially add a category of sustainability projects that we wouldn't have had before. And so that was roughly in the order of 400 million that was added in. And also the investment timeline increased up to the end of this year. So really what that pot of funds was intended to do was to address the climate action plan that had been released in the Republic, and sort of get us on towards 51% reduction of our baseline emissions by 2030, our Scope 1 baseline emissions, I should say. The previous iteration sort of had a reduced ambition, but that redetermination helped us address the climate action plan. So that's where our journey really began with geothermal. And one of the projects that came out of that whole pot of funds of 400 million euro was what we call the Terminal 2 T2 Sustainable Upgrade Project. For those of you familiar with Dublin Airport, there's Terminal 1, Terminal 2. There are some older terminal buildings, the North Terminal, Old Central Terminal building, but the operational terminals right now are Terminal 2 and Terminal 1. So we are targeting Terminal 2 with a sustainable upgrade. Really what it means is a renewable heating and cooling solution. So to help us get ourselves on the way to that 2030 target of 51% reduction. Now, that currently, the heating system is comprised of combined heat and power unit and 3 boilers, 3 heating boilers. And so what the idea is to get ourselves off those. They're currently midlife, so we wouldn't necessarily throw them in the bin right away, but we would look to transition off those. Just for context, T2, as it says here, it's a 15% of our total carbon emissions for Dublin Airport and 40% use of the total natural gas. So this project involved looking at the full review of the building envelope and the heating system, and the age of the terminal is from 2008, 2009, right before the great financial crisis. And so the building is sort of midlife. It'd be 17, 18 years old. But the scope was to look at this. This project was seen as a real enabler for us achieving our targets. The last thing to kind of note as we kicked off this project for the capital investment program is that it's what we call a stage gate project. So essentially, we at Dublin Airport get funds from the Commission for Aviation Regulation, CAR, and that's made up of different airlines and different ground handlers, et cetera, other stakeholders. And so what we did in the SIP period and the capital investment program initiation is we identified a pot of funds of 110 million through some analysis and educated guesswork, and really the stage gate process is intended to validate that once firmer costs are known. So that's why we call it a stage gate process. Some of the projects we do at Dublin Airport don't have the opportunity to do that, but this one did, as we sort of clarified on our solution. So that's kind of the setup. So what we did in 2021 is we happened to do a very, I call it a basic geothermal feasibility and options study. This was sort of on the side of our capital investment program, but it was the opportunity to avail of some funds to do a test borehole in what we call our Eastlands area of the Dublin Airport campus. So the Dublin Airport campus is quite large. We have an area on the east side, notably Eastlands, where there's a sports center, the Alsa Sports Center, and then there's a bunch of pitches and so on, tennis courts. So there we were able, and some just natural fields. So there we were able to do a test borehole and a thermal response test, and that actually identified some very positive findings. So the fracture geology was unexpected. Now, I'm not a geologist, so maybe I might find it. Maybe I wouldn't be able to make that observation, but anyway, that was interesting for us. Also, there was a high water volume, so we were sort of keen to explore that. And then there was actually very high effective thermal conductivity. So what we did with that information in 2021 is we did a very basic schematic design of the North Apron building. So what's not shown on the image there is our current Pier 100, where Ryanair flights would take off from Dublin Airport. So the North Apron has a Module 1, which is currently still in design, even from 2021. It stalled for a little while. It's back on the table. But what we did is we used that information from the Eastlands, which is a separate area of the campus, but it gave us some indicative view of the geology here to inform a design for the North Apron hangar buildings. So that's what was done back then, and then kind of parked. But that was sort of our first foray into geothermal, using some available funds for that. And then in 2022, we commissioned Atkins, a global multinational engineering firm, to do a desktop energy study for us. So what they did is they looked at Terminal 2, both the main check-in building and the area outside of the Pier 400, and they also looked at Pier 100. And there's reasons for this. Is we've segregated the airport into different heating and cooling zones. So there are two different zones you're looking at here, as they're quite remote from each other. But that was the scope of their study, was to look at the energy usage, energy demand, and sort of constraints on those two pieces of infrastructure. Didn't mean we didn't care about the rest of the airport campus buildings, but these were the focus areas back in 2022. And so what they did is they did essentially parametric modeling through IES, which is a whole building energy simulation software, and they calibrated it against metered data. So they were able to really get some valid, and thoughtful data around that. And what they did is they looked at, Atkins and ourselves looked at different interventions that could be made, whether it be fabric upgrades, demand control, ventilation, these kind of things. But significantly in terms of the overall heating reductions and cooling, we had some results for air source heat pump solutions and ground source heat pump solutions, and then also ground source heat pump solutions with heating and cooling. So there was real positive momentum in terms of that analysis, but then it was sort of put to the side, and that was only a desktop-based analysis. It did not rely on the previous borehole done in Eastlands, but it did sort of set the stage for what we could do next. So then in 2024, by this time I've arrived at Dublin Airport, so all our problems are gone. I'm just kidding. And so in 2024, we went through an internal governance approval process, even though we have these regulated funds from the Commission for Aviation Regulation. We have our own internal governance process where we stand up projects and progress them to different stages. So what we had set out there was to implement some of the immediate interventions from the Atkins study. So that was, electrical improvements, etc. Now, we didn't end up doing those for various reasons, but that was part of what we had stood up. And then more importantly, and more kind of grand scale, is we got approval to explore feasibility of what we termed a part centralized solution for heating and cooling. So that would involve both Terminal 2, Pier 100, and also some of our future campus infrastructure. So there's a current infrastructure application in with the County Council for a future Pier 500 and a future addition to Pier 100. I showed it on a few previous slides ago. So what it was intended to involve was a multi-stage investigation to look at air source heat pumps and ground source heat pumps in tandem. The images on the right are where we were looking at potential geothermal fields. So you remember me talking about Eastlands in the beginning of the talk. So the top image is the red and yellow sort of shapes, polygons, rough polygons are Eastlands area. And what those green bars are potential service corridors or bridges, or to get the geothermal resource back to the terminal energy center. And then the other red rectangle on the top image is our future Pier 500. So that was just a notional way of looking at what the study area was going to look at. The image on the bottom is further north in the campus. So you can see the two runways there, southern and northern runway on the left, and then most of the terminal infrastructure where that green rectangle starts. And what we had there is we have some campus lands that are kind of our northeast, what we call our Carkner stud area. And that was also an area of exploration. So the idea was to look at geothermal in those four areas, the three reds and the yellow, the amber, and then also concurrently look at air source. So do a real optioneering exercise. but the air source heat pumps would be directly adjacent to the building, the terminal, and the Pier 100. And that with the geothermal, we were potentially having to do some design changes to the heating and ventilation strategy for both Pier 500 and Pier 100. So that was kind of part of the original plan. And then because Pier 500 has a current infrastructure application with Fingal County Council, FCC, there was a possibility that we just were front up about this, that we might have to amend that infrastructure application. Now that none of that's happened, the application is still in, we haven't amended it, but that was sort of how we set out in 2024. Then what happened is towards the back half of 2024, we had a bit of a change of tack where we decided as a business to just proceed with geothermal study only at the beginning points. So we kind of put air source heat pumps to the side. We didn't shelve them, but we just didn't study them right away. And between February and September, we engaged GeoServe to do a detailed geothermal feasibility and initial systems design. So that involved our zones 1 and 3 areas. So back a couple slides ago, I had Pier 400 and Terminal 2 and Pier 100. Those are zones 1 and 3. And then there's future buildings in there, Pier 500, etc. So we had sort of a group of buildings we asked GeoServe to look at, and we characterized it to themselves and as part of the tender process to bring them on board as up to a 10 megawatt of thermal energy of geothermal capacity. So a very large installation in the context of the Irish market. There is an operational geothermal system at IKEA, which is a couple kilometers away from the airport, and I believe that's closer to 1 to 2 megawatts. So this was a sizable increase over that. So what GeoServe's scope was to start with an energy demand assessment, look at and sort of build off the 2022 Atkins desktop study, but do a deep dive in terms of our energy demands, both for existing infrastructure and for future buildings, looking at energy benchmarking from different standards, et cetera. And then from that, look at the subsurface geology, obviously, and do a series of non-destructive tests, both electric resistive tomography and seismic refraction testing. So that was part of their scope, and they didn't do that everywhere. They certainly didn't. They did it in areas that made sense. So we looked at sort of undeveloped lands, grass pitches, fields, etc. We stayed away from car parks and so on for various reasons. So that then led to siting of specific borehole locations. So we did 4 in total. We originally had 5 in the scope, and we trimmed it down to 4 for various reasons. And 3 of them were closed loops, and 2 of them, or 1 of them rather, was an open loop. So the closed loops were at 200 meter depths, and the open loop was at 100 meter depth. And the idea was that we would do thermal response testing on the closed loop, and then pump testing on the open loop. So that was the scope. The original scope was to do an additional open loop testing, but what happened in the investigation is we found very low water volumes, notwithstanding the work from 2021, where we had really positive flow rates. We weren't so lucky this time in where we sited that borehole, so we decided to take advantage of the lack of flow and sort of move it. We originally had planned to do boreholes in both the Eastlands area and our Carkner stub, but then we for various reasons we relocated one of those boreholes to a purple staff car park, which is closer into the terminal buildings. So the investigation was dynamic in the sense that we had a certain scope that had been agreed to, and then we changed it a little bit to suit the site conditions as we were finding them. And we were looking to deploy a 5th borehole, but we just sort of ran out of time and viable space to do that. So that's why we ended up with 4 test boreholes. As I said, we did thermal response testing, pump testing, and then one of the things that was included was also DTS fiber installations. So that fiber installation is really to help give an indication of long-term temperatures. So we've done a couple readings since then, since the original installation, to kind of validate that the ground temperatures are stable. I think they're about 12 degrees Celsius in the borehole that we've measured so far. We haven't been able to measure them all since, because some of the boreholes are in quite field-like areas where there's obviously been a lot of rain this year, and so we've been kind of waiting for those readings until drier weather. But the intention is to continue to monitor those long-term temperatures over time and kind of inform the system. And then I suppose Geoster's work finished up towards the back half of the summer with an initial systems design. So they looked at Terminal 2, which also included Pier 400. They looked at Pier 100, the Pier 100 mod building that hasn't been built, and the Pier 500 building that hasn't been built, and also future cargo buildings. So we are planning to relocate some cargo buildings from our south apron over to the Eastlands area. So they did systems designs for all of those based on the geology, based on the boreholes, based on the non-destructive testing, etc., and based on the energy demand. And then closing that all off, they did a life cycle analysis, I should say, to help us understand the energy and carbon savings for each. On the bottom were their partners that they brought on board, so Apex Geophysics, Geomax Surveys, and OPN Buildings, who looked after the life cycle analysis. So, and I don't know how they got lucky enough to get that plane overhead with the drilling, but we love showing that photo. So, key findings. I haven't listed the findings for every area. You might remember I talked about all those buildings in the last bullet point. But what I'll focus on today is our Terminal 2 and Pier 400 building, a group of buildings, and our Pier 100. So essentially what we found for Terminal 2 and Pier 400 is there was an easily plug and playable, if that's a word, shallow geothermal closed loop system that was available for the Purple Car Park. You might remember me saying we relocated one of our boreholes to the Purple Car Park to ensure we understood the geology closer into the terminals. And so what you see on the screen in the right image is a series of modules that were proposed for the systems design to service Terminal 2 and Pier 400. And so the idea being is that you would you wouldn't take the entire car park out of service at once. You would do it in modules of, I think there's 240 boreholes proposed. So you would do in 60 boreholes tranches or so, or 40 borehole tranches, I should say. That my math's off there, and inherently that ended up in a sizable reduction of CO2 emissions over 5 years. This is assuming it started in 2025, and we haven't deployed it yet. So this was kind of theoretical, but what that really meant is it's 125% of our 2030 Scope 1 targets as proportion to T2. So obviously we don't report that way. We don't report an individual asset level at the airport. We report globally, or at a campus as a whole. And this is a sizable component. And also importantly, there was free cooling available by increasing measure and up to 73% by year 10. And then annual energy savings of 656,000 per year. So really positive results. And then for Pier 100, we found similar results. We actually GeoServe actually looked at two solutions, a shallow closed loop and a deep closed loop. And the shallow closed loop was the winner because of the free cooling potential. So it had corresponding CO2 savings and as it's shown there, and free cooling even earlier, not earlier, but a certain proportion of free cooling by year 10. And then corresponding energy savings. So those were sort of our key findings. The report is much larger. Obviously, it's about 300 pages, but these were kind of some key findings that I thought I'd share today. What I've got on this slide is the long-term temperature ground performance for T2 Pier 400. So T2 Pier 400 is heating dominated, so there's a longer-term reduction in the ground temperature. But inherently, over those 50 years in the simulated scenario, the water temperature is always above 5 degrees in heating, and as it says here, we were able to maximize free cooling after initial operations. So what you've got on the top graph is the 50-year period. The bottom graph is in year 50. What that temperature fluctuation is throughout the year. So what did we do since? What did we do after September? Well, you might recall I said we were initially going to look at concurrently ground source heat pumps and air source heat pumps optioneering at the same time. We didn't do that. We did the optioneering at the end. So we did that optioneering last autumn to help in our business decision. So we actually got a separate consultant to come in and do that optioneering and pick up on GeoServe's work and analyze it from a carbon and energy perspective. In GeoServe's scope was not to do a service corridor over to the energy center of T2. So what you see in the top image is the service corridor very, very notionally. So there's a couple options that are shown on the screen, but the Purple Car Park are all the dots in orange, and then there's collectors obviously in there, and then the dark green is one route and the light green is another route that we had proposed. And then where that green dashed line ends is the Energy Center. Terminal 2 is just adjacent to that on the left side. So that hadn't been part of GeoServe's scope, so we ended up getting that designed at a very schematic level and costing that, because that was an important cost to consider it form part of the overall scenario. We did the same thing for Pier 100, a different well field. So that well field is over near some of our commercial buildings. We call them Dublin Airport Central. So that's in the bottom image. You can see Terminal 2. It's like kind of the I can't describe the shape, but it's the image. It's the building on the bottom, and then the well field is kind of across. There's a multi-story car park just adjacent to it, and there's some commercial office buildings. But there is some land available to do boreholes there. And the idea is we would run that close to our north apron in a service corridor over to our Pier 100 building. So that was costed and designed as well. So that was what we did in the autumn, and then we hadn't done number 3 yet. That's something that was recommended, but we haven't done that yet. So additional energy load analysis and monitoring to really refine the design for Pier 100. The last 2 items, they're more conceptual, I would say, as to what had been recommended, and what we were starting to look at was new build briefings and conceptual geothermal documents to be revised at the development stage. So if the business were to decide to progress with geothermal, then we would have to kind of further enhance that. And then the last one is number 5 on the screen there, is looking at other new infrastructure and how do we embed geothermal in those projects, because it's in speaking candidly, geothermal hadn't been part of any of our building designs up to this point. So that was what we started to do in October of last year. Up to this present time, we're still looking at that. And so one of the things where we're currently at right now with this, like, we're still on the journey. We're not at the starting line, but we're not midway yet either. We're partway through. But we kind of came up with these 4 key elements that we're studying. Right. The first one ties back with the last one on the previous slide, which is embed geothermal, or GT, in all new campus buildings. So the way we can kind of present that business case to the decision makers is to look at a reference building. So we have several pieces of new infrastructure, new campus infrastructure, that are being designed and built over the next 5 to 10 years. So the idea is to pick one of those buildings and study that from a desktop standpoint. We're not planning to do per se more boreholes at this point, because we understand the subsurface geology sufficiently enough, and we understand the energy demand. But it's looking at a specific reference building that's not built yet. So obviously the study did have some of that, but it's to kind of flesh that out further. So that's one of the things we need to kind of stare into and dig into. We haven't started that yet, but we're in the planning stages. The second one is to refine the business case for geothermal terminal 2. You might remember me saying that service corridor was a cost that had to be added to GeoServe's design and costing for the geothermal well field. So that service corridor, in the distance, I think it's about 500 meters for Terminal 2. The distance for the service corridor for Pier 100 is 1,000 meters. So it's quite substantive, and the costs are quite significant. So the idea is that we would point B, 2B, is to localize the geothermal wells, get them closer into the energy infrastructure, our plant, for lack of a better word, to reduce the complexity and cost. So that's something that we're looking at very closely now. At the same time, one of the recommendations coming out of the systems designed by GeoServe was to decouple domestic hot water from primary heating. We'd been thinking about this for a little while at the airport, for some of our buildings and for T2. So that project has started now, and what that'll do is that'll help us reduce the flow and return temperatures for our heating and cooling, because right now we're servicing hot water, domestic hot water, and heating and cooling from the same boiler. So if we can get that decoupled, then we can introduce lower flow and return temperatures, which can have a better, more beneficial impact on geothermal. And then there will be some electrical infrastructure upgrades, whether we go geothermal or air source heat pump or a hybrid. There will be definitive electrical infrastructure upgrades required. So we hadn't studied that per se. We studied it very notionally in the original design, but that's what we've asked the business to consider. So that's number 2, and then number 3 is, which I got a bit more detail on the next slide, is our Pier 100 Mod 1. Instead of using that service corridor proves too costly, we're looking to locate them closer in. So that's what that first one is, A. And then I won't touch on B, but C, it's quite novel, I would say, for the airport to be thinking of this, and we'll get into that in a few minutes. But it's really to look at other remote lands that we can leverage for geothermal wells for a number of different buildings. And then lastly, we're looking at Pier 500. So this was looked at in GeoSurf study, but we want to further develop that design with the recommended geothermal wells under the building, so no need for service corridor, and then complete an HVAC redesign. So that's a necessary requirement to do that. And that the challenge with that building is it's currently in an infrastructure application, which hasn't been ruled on for various reasons. So we got to keep faithful to what we kind of put into the local county council. Okay, so here's a little bit more detail on what we're thinking with Pier 100 and Mod 1 to 3. So Pier 100 is existing and Mods 1 to 3 do not exist yet. We're currently in the detailed design for Pier 100 Mod 1. So the idea is to introduce geothermal wells under that footprint. So that's the top image outlined in red, the geothermal boreholes and little dots and different pieces there. So that's one. And GeoSurf had done a systems design here for that. So they talked about 42, or they estimated 42 boreholes at 195 meter depth. So that would be that would really make the best use of the real estate we have. And that's a shallow closed loop solution. Then probably more novel is to look at a remote geothermal site. Notwithstanding that I said the service corridor was a non-runner for some of the buildings, we're currently developing that area in the yellow box for solar, or we're in the concept design stage for. So that's some lands the airport owns. That happens to be an area also near where GeoSurf had studied from a non-destructive standpoint, our Carkner stud area. So that area is going to be built up with solar panels. It's currently fields and hedgerows and so on. And so the idea would be to look at, could we double purpose the asset, the land asset? Could we do geothermal and solar panels and then connect it across with the service corridor? Whether we connect that across immediately or whether we wait, but knowing we have that resource there. So we're studying that, and really probably the key area there is we're trying to safeguard the new build designs for both air source heat pumps and ground source heat pumps. If we have that asset, we're able to tap into it. So that's what we're studying right now, and I think it's very exciting. And there's time pressure on us because we're looking to get that solar farm built, so and get in for planning, etc. So that's where we're at with Pier 100 Mods 1 to 3. And that's kind of where the journey is at right now. We haven't progressed it further just yet. It's Joe and I talk about this from time to time, but it's a slow journey for critical infrastructure such as this, where we really have to study it carefully and make sure we're looking at the options appropriately. To put it in context of what the airport is doing in general in sustainability and decarbonization, is we are I already sort of mentioned in passing, we are doing solar PV and battery storage. We've got an existing 9 megawatt peak solar farm in the southwest of our campus, and we're planning for one in that area on the previous slide right here, in the northeast of our campus. You might wonder why those solar farms are so remote. Well, there's really, why they're not sort of closer into the airport, there's glint and glare considerations we've got to be cognizant of, and so we've got to be very careful of that. Anyway, we're continuing to do that. We're looking also at battery energy storage, which we haven't deployed yet, because we feel that's necessary as the airport grows, as we decarbonize, as we electrify heat, as we electrify transport, and as we grow the airport. So those are key pieces. Touched a lot on the renewable heating and cooling through the entire presentation, and then power and utilities. You might wonder how that's connected with sustainability focus. Well, the airport operates a very large, one of the largest in Ireland, if not the largest, medium voltage network, 10 kilovolt medium voltage network, and so that network is under stress. It's aging, it needs expansion, it needs resilience. So a lot of our focus here at the airport is to address our power and utilities programs. We've got a number of projects. I have them on another sheet here that I'm just reading off of, but we're putting in a new incomer station, a second connection to the DSO. We're doing a condition survey of our MV network in our landside area. We're constructing 3 new medium voltage rings and providing ducted MV infrastructure roadmap. We're ideating and procuring and designing a microgrid, which is basically a central brain for the airport to manage the renewable energy assets and the loads. We're doing medium voltage power metering, electrical network model updates, and then we're doing a utilities master plan. So all of those kind of fall under power and utilities, and they're not per se sustainability or decarbonization plays, but if we don't do them, we're going to be in real trouble of affecting our renewable heating, cooling, and solar and other strategies. One of the other things we're looking at too, on the bottom left, you see micro wind generation. So that you wouldn't necessarily expect that from an airport, but we're trying to take the lead from counterparts in Edinburgh, Scotland, where they're looking at it very seriously. So we're starting to study micro wind generation. We're talking low level wind, 2 meters or lower. And then, as Joe mentioned in the bio, we secured some grant funding last year for campus electrification. That was electrification of vehicles. So fleet vehicles, passenger buses, that kind of thing, that within the airport campus. And we're also looking at grants for things like geothermal. They're hard to come by, but we are looking at them and trying to be as creative as possible. So that's really where our journey is at present. It's not ended, it's not begun. We're in the middle of the journey, and happy at this point to take any questions. I think I'm bang on time for what we had agreed. So happy to take questions.